So in the last session, we were talking about the implementation of the linear regression, and that point we were talking about because of the first point in the third unit. That was the point which was related to linear model. So we were discussing about implementation of linear model. So let me straightforward go to the Jupyter notebook. Right, this is what we were talking about in the last session. So if you remember, we have already seen the data set. We already understood the data set, and our problem statement was to create a model which is going to help us to predict the chance of admission for of a student to foreign university for MS or maybe for any degree. Right. So the first step we have done is importing of all the necessary library. Okay. After that, this is something which we are going to make use of, which is called as adjacent R square statistic. Right. This we are going to make use of once our model is developed, just to check how our model is actually performing, whether it is giving us the good accuracy or the bad accuracy, or whether it is giving us the accuracy up to the expectation or not. Right. Next step, what we have done is we started with the importing of the data set. So this is what I have explained you in the last session. After that, we have used a method on data frame, and that is nothing but describe method. So I told you that describe method is going to give you a lot of idea. For example, it shows you what is the count in each column, what is the average of each column, standard deviation, minimum value, then quartile 1, quartile 2, quartile 3, and maximum value. And here we notice that in GRE column and TOEFL column and university rating column, number of records are not equal to 500, or number of records are less than 500. It means what? It means there are some missing values in these three features, in these three columns. Right. So this is what we came to know about our data from this describe method. Again, describe method is the default method available in Python, and which is available for a data frame, because this data is our data frame in which we have our whole data set from admission underscore prediction.csv file. And yesterday even we have I shared that particular file with everyone. So as we have seen that there are missing values, so just to handle those missing values, I told you that we are going to apply something called as imputation. Imputation is simply what? It is simply handling missing values or replacing the missing values with average, that is mean or mode or median, depending on what type of a data you have. So this is what imputation we have done, and we handle the missing values. And once the missing values are handled, we again check with dot describe command, and now this time we have seen that in every column, in every feature, number of records are same, that is 500. That means there is no missing value, null value, or any value, right? Then we moved forward, and we actually removed serial number column, because serial number is not going to contribute anything to the output. After that, we plotted some graphs, we plotted some plots, just to know how the distribution of the data is. So for that, we have used the packages like matplotlib and seaborn. So here we have seen that even though there was a skewness, but it was negligible, and that, yes, that can be ignored. So almost more or less our data was looking like normalized data or symmetrical data. I told you what is normalized data. So that's why we plotted these graphs. After that, we divided our data into input and output. So chance of admission, this particular column is assigned to y variable, right? And all the other columns except chance of admission are assigned to x variable. After dividing the data into input and output, then we move forward, and we actually try to see the relationship between all the input columns and the output column. That is relationship of all the input columns with chance of admission. Right. So for that we used matplotlib package, and we plotted scatter plot. Again, it's not necessary that you should also go with scatter plot. It all depends on person to person, or it all depends on which types of plots you are actually good, right? Or maybe it depends on the situation, it depends on the data. But yes, most of the times you will see that scatter plot is going to do your work. So here we plotted scatter plot with the help of matplotlib package, which is available in Python, just to see the relationship between input and output column. Right? In our case, there are 7 input columns and 1 output column. Output column name is chance of admit. So we have seen that here we notice that almost the relationship is linear, and that was like one hint for us to go with linear regression, right? So if you see, the relationship between the dependent and the independent variables look fairly linear, and thus our linearity assumption is satisfied. So it's like something it's something like hint for us to go for linear regression to solve this type of a problem. After that, yesterday even I explained you about standard scaler. I told you standard scaler we make use of just to make sure that everything is at the same level, right? So standard scaler is a package which we already imported. I already shown it to you in import statements, and we talked about something called as VIF, variance inflation factor. So just to repeat it, I will tell you that why we are making use of something called as VIF, because VIF tells you whether there is multi-collinearity present in your data set or not. Now, what is multi-collinearity? What is the meaning of this particular word, multi-collinearity? So yesterday in short I actually talked about it. Multi-collinearity, it means that if there is a relationship between one independent column and another independent column, that is called as multi-collinearity. See, if there is a relationship between dependent and independent column, that is no problem, but there should not be a relationship between one independent column and another independent column. So if it is there, then it is called as multi-collinearity. And multi-collinearity should not be present in the data set. If it is, what will happen because of that? If there is a multi-collinearity in your data set, and if you try to create the model, if you try to train the model with that type of a data set, your model is going to become overfitted model. And we already talked about this particular term, overfitted model, right? Overfitted model is the model which will give good accuracy at the time of training, but very less accuracy at the time of testing in real time. And that's what we do not want. And that's why what we do is we use something called as VIF, variance inflation factor, again, which is available in statsmodel.stats.outliers underscore influence. So if you remember, you already imported this particular package in the import statements, in the initial import statements. Okay, so someone is asking what is independent and dependent data. Can you repeat? So I did not say independent and dependent data. I said independent features and dependent feature, or independent column and dependent column. So I already talked about it, right? Independent columns are nothing but what? Input columns. Independent columns are nothing but what? Output column. That's it. Is it clear, Sharon? If independent column means inputs, dependent column means output. There are different terms which are used for that, right? So one independent column should not be dependent on another independent column. If it is, then it is called as multi-collinearity, and multi-collinearity should not be present in your data set. If it is, and if you go with the same data and train the model, your model is going to become overfitted model. So just to make sure that whether there is a multi-collinearity present in your data set or not, we imported this particular method. Now, how it is going to help us? So, if the value of VIF for a particular feature, for a particular column, for a particular independent feature, if the value of VIF, if it is greater than 5 for that particular column, it means there is a multi-collinearity present in the data set. So, what we're going to do now? So, in this case, what are we doing is we are creating an empty data frame. And then what are we doing in this case? So we are trying to add a column called as VIF and another column called as features. VIF column and features column. Under VIF column, we will be having VIF value for each feature. Right? So if the value is greater than 5, then there is multi-collinearity. And if it is not, then there is no problem. But what if it is there? If it is there, so to remove multi-collinearity from the data set, there are 3 to 4 steps or 3 to 4 ways. Suppose let me show you what happens in our case. Because of VIF, we got this particular data. So if you can check, for GRE score, VIF value is less than 5. TOEFL score, VIF value is less than 5, and so on. That means there is no multi-collinearity present in our case, in our data set. It means what? It means there is no independent column which is dependent on another independent column. So if you can see, we have actually try to find out the VIF value only for independent columns, only for inputs, not for output. Okay, because if you people have understood the meaning of multicollinearity, you will get what I am trying to talk about. Those people who have attended from the start, definitely they will get it. Okay, but what if the VIF value is greater than 5 for some column? In that case, to remove multicollinearity, there are different steps which you can apply. So to remove multicollinearity, there can be a question in your exam. Okay, this is the way to remove multicollinearity. So remember, whatever I am discussing, everything is important, at least for your exam point of view. So to remove multicollinearity, what you can do is, the first thing is directly remove that particular column or drop the column. That's it. Drop the feature. Otherwise, add that feature with another feature, right? That is, combine that feature with another feature. See, if I want to talk about multicollinearity in simple words, it can be something like, suppose, see, I have some columns like number of experience, okay, or experience in years. This is the column I have, and another column is, suppose, education, right? And the next column is, suppose, salary, right? Now, suppose this is what the data is. Now, our problem statement is, we want to create such a model which is going to help us to predict the salary of the employer. Suppose number of years is 10, numbers of years of experience is 10. Education, suppose the levels of education are 5. Out of 5, education level is 3. So salary is, suppose, 80k. Okay. Number of years of experience is 9. Education level is 4. Suppose salary is 85k. So like this, we have a lot of data. Now the question is, you need to create such a model. Given these features, your model should be able to predict what will be the salary. But in this case, first of all, you need to check whether there is a multicollinearity present or not. So see, if you can, if you can see here, as I have written numbers of years of experience, right, and education level. These are the two things, right? Now, what do you mean multicollinearity? That means if these two are the independent columns and if this is the dependent column, that is, if these two are inputs and this is the output, so this one should not be dependent on this one, or this one should not be dependent on this one, right? If they are, that means there is a multicollinearity. And how do we check that? We just check with VIF. If the value of VIF for any column is greater than 5, then that means there is a multicollinearity, right? So in this case, suppose, just assume that there is one more input column that is called as age, right? Suppose it was also given there. Now, just try to see, isn't there a relationship between age and experience? Isn't there a relationship? Yes, it is. See, given the years of experience from the joining, for example, or maybe given this age, you can calculate numbers of years of experience, right? So suppose age at the time of joining. Age at the time of joining of a person was 25 years, and total years of experience he has is 10. So obviously you can derive the age, right? So given some constant, given some constant, you can derive other column from some another column. From see, actually it is happening like this. Age is equal to numbers of years of experience. Given some constant, you can derive age from numbers of years of experience. So what was the age of that person at the time of joining? 25. What is his experience right now? 10 years. So 25 plus 10 is 35. That means these two columns are dependent on each other and they are independent columns. And one independent column should not be dependent on another independent column. If it is, then there is a multicollinearity. So this is called as multicollinearity. So to remove that, either you remove the column or you combine them. Now, what do you mean by combine? That means instead of using these two columns, instead of that, what you can do is, for example, in this case, what you can do is we can combine these columns. How? Just create only one column by combining these two columns, maybe like seniority level. So based on these two, create only one column, that is seniority level. That's it. Obviously, automatically multi-collinearity will be removed. Third way is like you can make use of something called as principal component analysis. Again, which is not there in your syllabus. But yes, principal component analysis, many people think that it's an algorithm to create the model. Actually, it's not. It is the algorithm which we generally make use of in pre-processing steps of the model. Right? So PCA is also one of the techniques which can be used to remove multi-collinearity in the data. Okay, so these are the ways. But in our case, if you check, there is no value which is greater than 5. That means there is no multi-collinearity in our case, right? So we are good to go. After that, now we are dividing our data into training and testing. So before starting the implementation only, I told you that how we divide the data into training and testing. So we are going to make use of a method called as train test split, which we are already imported. So our dataset name is what? X underscore scale. If you remember, now we have already scaled down the data and we have stored all the input data in this particular variable. Where in which variable we have output? Y variable. What is test size? Now see, what do you mean by test size is equal to 0.25? It means that testing data is 25%. Obviously, it means training data is how much? Remaining 75%. So I already told you, generally it is 70-30%, but it can be 25, 75, 85, 15, 80, 20. Right? And random underscore state is equal to 355. Instead of this 355, it can be 1000, it can be 42, whatever you want. What is the meaning of this? It means that whatever the data which we are going to divide into training and testing, that will not be in sequence. It will be random. Right? See, what are we doing now? How many number of records we have? 500 number of records. Out of 500, 25% are testing. Right? So that means 25 means 125 number of records will be assigned to test data and remaining how much? So 500 minus, so this 500 minus 125, whatever is remaining, this is 375. So 375 number of records are going to be assigned as training data, right? But these 125 number of records are not going to be in sequence, they are random. So they are going to be random because of this particular argument. And same is the case for 375. Obviously they should be random, right? In random data, so they will not be in sequence. But obviously 125 number of observations will be for testing and 375 observations will be for training. So actually we are going to train the model based on 375 number of rows. So this is the step to divide your data into training and testing. If you want to see all the values, you can check X train. So if I say X means what? Input. Train means for training data. So obviously, how many number of records should be there here? As it's a training data, that is 375. X test means it's a input data, but testing data, that means 125 number of records, right? So someone is asking, sir, does randoming of data increase normalization output? Normalization output, what do you mean to say? I'm not getting your question, Sharon. Does randoming of data increase normalization output? Now, what do you mean by that? Normalization is we already we already tested for normalization. Our data is already normalized. Normalization means what? Your data distribution should look like this. This is called as normalization. Okay. Randomizing. Why are we randomizing our data? Why are we taking random records? Because who knows, right? It is going to take first record, then 25th record, then 75th record, then 60th record, maybe 100th record, then maybe 400th record. So it is taking randomly. Every record has different values, right? So our model should be properly trained. Yes, after normalization. After normalization only we randomize. This is where we are done, right? Randomizing the data. Okay. So you can check X train, X test, Y train, Y test. So wherever there is testing data, it means 125 number of records. 125 number of records. Training means 375 to 70 because of this particular argument, right? Later on, once you get this particular file, I will recommend that go and execute and check all the number of records. So see, if you see y underscore train, so y is the output, but train is the training data. So that means 375 number of records you are going to see, and they are random. See, 378 record, 23rd record, 122nd record, and so on. So random because of this particular method, you are able to see random records. Now, so like this, you could have trained, you could have actually checked for explain y train, x test, y test, all those things. Right. Now is the time to apply linear regression on the data set. So first of all, you need to call linear regression method which we imported earlier. So this is how we are going to call linear regression. And here what am I doing? I am creating an object called as regression. And this is actually called as training. Regression. So see, regression is a variable. Regression is an object of the type linear regression. Right. We created the object of the type linear regression and we named it as regression. Again, it's a user defined name. What I can do here, regression dot fit. What is X train? It's a training data, input training data. What is Y train? It's a output training data. So based on input and output, so in input we have 7 columns, in output we have 1 column. So based on this input and output, we are just trying to train the model. Okay, so this is actually the training. So whatever the things which I have explained you in theory, all those things will be done here at the backend. Same, exactly same logic will be followed, right? But yes, obviously there are some other things also which are actually considered. But yes, they did not mention all those things in your syllabus, right? So in this case, I will have to limit myself up to this point only. So yes, this is the actual training. Now, how to save the model? So what am I doing is I am creating a string with this name, finalize underscore model dot pickle, and I am assigning that particular string to file name variable. And pickle is the package. I already told you pickle is the package. So what am I doing is pickle dot dump. Now what I have done here, I have created a variable object with the name regression. Now what we want to do is we want to save our model into this particular file, finalize underscore model dot pickle file. So my model is here in this variable. Now I am just going to dump that particular model. That means write that particular model where in this file name. What is assigned to file name? So to a file name, we have assigned this particular name. That means this particular line is doing what? This particular line is simply dumping, simply writing whatever was there in this. It is simply writing it down here. Right? See, open is a method which is available by default in Python. So we are trying to open a file in which mode? In write and binary mode. Binary means what? Binary means executable. W means write and binary mode. So that means what? That means whatever the model which we have trained till now, that model is going to be written in this file. That means it is going to create a file with this name, finalize underscore model dot pickle. If you want to see this file, I can show it to you in my working directory. So if I go and if I try to show it to you in my working directory, you will be able to see a file with the extension .pickle. Finalize underscore model dot pickle is going to be the name of the file. So if you want to see it, see this one. This is the file, right? So how I am able to see this particular file? Because we have dumped it. We have written everything. So this is like an executable file. Now you make use of this particular file anywhere you want. You will be able to predict, right? And how are we going to make use of that file in real time? That I will tell you. See, this is all about creating the model, right? This is all about creating the model. Our model is ready now. Now, if you want to go and if you want to do the predictions, yes, we can do that. So first of all, you need to load the model for that. So what I am doing is pickle.load. Load is the method to load the model. Pickle.load, open. What to open? File name. What is assigned to file name? This name, finalize underscore model dot pickle. So I am trying to open a file, this particular file, this dot pickle file in read and binary mode, because I want to make use of that. And I am storing it in this particular variable. And what am I doing now? Loaded underscore model dot predict. So dot predict is the method now I can apply to predict, right? And scalar underscore scalar dot transform is just to scale down the data. Now, what are these values? So here I am passing the input values manually. What is this 300? This 300 is the GRE score. What is this 110? This is the TOEFL score. What is this? This is statement of purpose. What is this 5? This is letter of recommendation. What is this 5? This is university rating. What is this 10? This is CGPA. What is this 1? Research done. Right? All these are the input columns. 1, 2, 3, 4, 5, 6, 7 input columns. So once you pass all these input columns, all the input values, all these input values to our model should predict. So our prediction is stored in here. And now it has given us the result as 92. That means if the student is having 300 marks in GRE, 110 marks in TOEFL, and 5, 5, 5, 10, and 1, all the input features are like this, the chance of the admission in foreign university for MS for that student is 92%. Right? This is what the prediction which is done by our model. And now if you want to go and if you want to check the R-square statistics for the model, you can do that. See. This is how you can find out the R-square statistics. Regression.score, X train, Y train. So for training data, our model has the accuracy as 84%. That means 84%, 84 number of times out of 100, our model is going to give correct results. Obviously, this can be improved, right? There are different techniques in machine learning which can be applied to improve the accuracy of the model and which we make use of in real time. But again, that is not there in your syllabus. Right? So R-square statistics I have seen, and now see adjusted R-square statistics. At the start only I have shown you that we have written one function. So R-square statistics is like accuracy is 84% and adjusted R-square accuracy is also somewhat near to 84%. That means there is no that much major difference between these two. That means if there is no that much of difference between these two accuracies, that means we are on the right track. If there would have been a lot of difference, then we will have to make use of some techniques and then again go for retraining approach and try to see why actually we got the less accuracy. Okay, but yes, in this case it is good as there is less difference. And similarly, you can go for checking the accuracy for testing data, X test, Y test. So R-square statistics for testing data is 75 and adjusted R-square statistics for testing data is 73. I told you this can be improved, but there are other techniques which you need to make use of. But the thing is that they are not there in syllabus. That's why maybe we can skip them here, right? Because again, if I go and if I try to discuss all those things, it will take a lot of time. And obviously, all these things also require practice, which I do not know whether you people are doing the whether you are performing everything on your own or not. Right? I don't know whether you are referring to videos or not, whether you are referring to all the notes which I have shared or not, or you are just preparing only for your exam. I don't know. Right. Okay, Manas is asking, sir, can a confusion matrix be used to check output prediction for any algorithm or is it only for linear regression? First of all, Manas, confusion matrix is not for linear regression. Okay, confusion matrix is not for linear regression. Manas, just try to understand linear regression is the thing which we are trying to understand here. The term confusion matrix is used to check the accuracy of classification problems. Is it clear, Manas? And the problem which we are trying to solve here is not a classification problem. The problem which we are trying to solve here is a prediction problem. Right? So we do not use confusion matrix for prediction problem. We use R square and adjusted R square statistics. And yes, obviously, later on there are other accuracies also which we make use of. But remember, confusion matrix is used for classification types of problems. It means suppose if you have a medical data, so you need to classify depending on the symptoms of the patient. You need to classify whether the patient is positive or negative, right? Or patient is diabetic, non-diabetic. Those types of problems are called as classification problems, right? Or maybe if you want to see, if I want to tell you practical application, You people are using Android phones, right? So you might be knowing about Google Photos. What happens in Google Photos? If you go and if you click a photo with friends, right? So that photo will be stored in one separate group where you will find out all the photos which are which you clicked with your friends only. There are photos separate group for families. There are separate groups for suppose maybe nature's photo. So in those kind of problems can be classification type of problems to some extent. Okay. But yes, here we cannot use confusion matrix because it's not a classification problem, it's a prediction problem. Right. So yes, guys, this is what I wanted to tell you. Now, obviously, there are a lot of things to discuss about linear regression here, but yeah, we need to limit somewhere because see, I explained everything here. Polynomial regression is what? When to use polynomial regression? Here we have used multiple linear regression. Okay, simple, multiple, I told you, but polynomial is not there in your syllabus. They are simply explain linear model. That's why I explain linear model, right? But yes, yeah, obviously there are a lot of things to discuss. But let me tell you what after this. Suppose if you this is a very simple model, okay, very simple model. But still, if you really want to know what to do after this, even though we created the model, right? So our model is stored in a file with this particular name, right? With the dot pickle extension. So let me go to that particular file, and yeah, our model is stored in this particular file. Now what after this? How to make use of this kind of a model? Okay, so that's what I'm going to tell you now. How to create a front end and how to make it user friendly. Okay, so Saloni is asking, sir, normally we use dot score for checking the accuracy. Then what is the significance of using adjusted ASCO statistics? That's what I told you, Saloni, yesterday. That's what I told you yesterday. Why we use adjusted ASCO, right? See, I will repeat it once again. I hope other people are also getting Saloni's questions. She is asking if we are using dot score for knowing the accuracy of the model. Why we use adjusted R square? So try to listen here slowly. What happens is dot score is nothing but what it is called as R square statistics. R square statistics, which I told you that it is mentioned in my notes, but it is not mentioned in your syllabus. If you want, you can go and you can see the formula. Even yesterday also I showed you the formula. So you are right. We check with R square statistics. Your question is, see, her question is why we use adjusted R square statistics. We use adjusted R square statistics even though we have R square statistics because of the limitations of R square statistics. Now, what is the limitation of R square statistics? See, suppose now in our case, how many number of input columns are there? So if you remember, if you have carefully looked, we have 7 number of input columns and one output column, right? 7 input columns were there in our case and one output column was there. It was chance of admission. So if you go and if you try to see the R square statistics for your model, suppose R square statistics is going to give you 90% of the accuracy with the 7 columns. Okay, but the limitation of R square statistics is that if you go and if you try to add such a column which is never going to contribute to the output, still R square statistics is going to increase. Are you getting? Even though you try to add such a column which is never going to contribute to the output, but still you will see that R square statistics value is going to increase, right? But adjusted R square statistics is not going to do that. See, obviously, value of R square statistics should be as high as possible, but value of R square statistics increases even though you try to add such columns, such features, such independent variables, such inputs which are not contributing to the output in reality. Still R square statistics value will increase. So just to have a control on that, we use adjusted R square statistics. If you people remember the formula which I have shown you in yesterday's session, there was something like n minus 1 minus p, something like this, n minus p minus 1. So this p is nothing but number of predictors, that is number of columns. So adjusted R square statistic keeps the track of number of input features. And that's why even though we have dot square, we use adjusted R square statistics because of this limitation of this R square or R square statistics or dot square. Is it clear, Saloni? Are you getting my point? Is it making sense? Right. So yeah, I hope you are getting it. Now, moving forward. Now we have this particular file. Let me directly show you how we make use of this file. See, we use notebooks just for pre-processing purpose. In reality, what happens is, even also we work on projects, we make use of notebooks just for pre-processing purpose. And let me tell you, see, a person may be belonging to any background. A person may be belonging to mechanical, electronics, ENTC, computer, IT, even a person from management background, anyone can do this. If you go and if you try to see data scientist team, in data scientist team, you will find out Python developer, Java developer, data analyst, business analyst, right? People belonging to different background. That's why domain is not a restriction for this kind of a field. Always try to understand. Otherwise, people feel that okay, I am not from a programming background. Why I should go and why I should study? No, it's not like that actually. It's becoming an interdisciplinary field now. You will see AI everywhere, and data science is actually a part of AI, which we have seen. Right now, see what happens is I want to tell you how are we going to make use of this particular thing. Now, as our model is trained and we have saved the model here in this file, .pickle file. Now let me show you what we do is whatever we have done till now, we have actually performed all those steps in Jupyter notebook, right? But if you want to go and if you want to create a product kind of a thing, you need to make use of something called as IDE. Jupyter is a notebook, but after that, we need to make use of IDE, Integrated Development Environment. And there are different IDEs which are available in the market. For example, there is an IDE called as PyCharm. There is an IDE called as Visual Studio Code. Some of you might be knowing about NetBeans. Some of you might be knowing about Eclipse. And number of them they are available. Generally, I make use of these two. And I prefer this one, PyCharm. Again, not limited. You use any one of them, but generally, whenever you talk about Python, people prefer these two. PyCharm and VS Code. Right. So now I am going to show you how I am going to make use of this particular file in the application of the project. Right. Let me go to the location where the code is already written and let me show you what you are going to get as a final product. See, these are all the files which we need for creating an application. Now, this is the file which I have shown you just now, right? This is the file. This app.py is a simple Python program. That's it. That's what you need. Now, what I do is I select all these files or just right click here and I am going to open all these files in PyCharm ID. Don't worry if you are not aware about PyCharm. Maybe if we get time later on, I will explain you. But here, what I want to show you is I want to show you that once we create the model, the way we created the model, finally underscore model of pickle, I want to show you that how we actually make use of that kind of a file in real time. That's why I am trying to show you a simple example. Right. So after that, you generally make use of IDEs, Integrated Development Environment. So whatever you people are able to see on my screen right now, it is loading something. What it is loading, it is actually loading PyCharm. Right. So again, it is not limited that you should have a PyCharm IDE. I told you there are different IDEs which are available. If you go and if you try to learn same thing from some other people, definitely they might prefer something else, right? But most of the times you will see people prefer PyCharm because there are a lot of things which are very easy whenever we talk about PyCharm, right? So PyCharm is simply an IDE where you can write down your Python code. But why I did not start with PyCharm initially? Because if I would have started with PyCharm directly, then it would have been very difficult to understand directly. But yes, obviously for applications, for projects, generally we make use of this PyCharm ID. Okay. Now let me show you. See, what happens is generally whenever we work on some project, we need to create environment. Okay. So don't worry about this code even if you are not understanding anything. But let me tell you, it's a simple Python code. Those people who have practiced from the day one itself, when they started with the sessions, obviously they will get these things. If you at least once go through the code, definitely you will get it. But I am not expecting that you should get each and everything from this. I am just expecting that you should understand the flow. At least you should understand whatever we have done till now, why we have done that. This is what I just want you people to understand. That's it. I do not want you to understand each and every line of the code. Not at all. But yes, those people who have done it from the day one, definitely they will get it. That will be good. If they have done it, that will be really good. But still, I am not expecting. See, this is the file which we have got from Jupyter, right? And how we have got it? All the steps I have shown it to you. Now, let me just double click on this app.py. I told you this app.py is simply it's a simple Python program, right? So this is a Python code, and it's not difficult to understand. But what I will do now is I will directly go and directly run this application. In this application, what we have done is we have created a graphical user interface. What I have done is I have written some HTML pages. Those people who are good with HTML, or those people who are good with some another scripting language, they can go and they can write down it. But let me tell you, this is not your job to write down the HTML page. There will be separate guy to write down the HTML code, or even you can go and you can just copy paste the code from any HTML website. That's also possible. So whatever you are able to see, static templates, these are the standard folders. These names are as it is. Okay. Don't worry about all these things. Let me show you a final product here. See, I will go to run and directly run this code. Now you will be able to see HTML page, front page. Definitely, first of all, it will show us a link, and whatever the link I will get, I will just copy that link. Now see, now this particular project or application is currently running on my machine. If you see 127.0.0.1, this is actually local. Let me go here. Let me copy this link. Let me go to the browser and open a new tab and paste that particular link here and hit enter. Now see, this is the web page and this is the HTML page and I am able to see. Now anyone can make use of your application, right? Instead of so see, obviously even the person is not a technical person, he or she should also be able to make use of your application, right? So now see, you can enter all the values. GRE score, you enter any value out of 340, 1 to 340. Profile score is out of 120. University rating out of 5. Statement of purpose out of 5. Letter of recommendation out of 5. CGPA out of 10. And research done or not. So yes or no. So if I go and if I click here, yes or no I can select. And then click on predict. So you will get the chance of the admission of the prediction of that person. Let me clear it. Let me show it to you. See, suppose a person has got out of 340 person has got 312 marks. In TOEFL, person has got 100 and suppose 14 marks out of 120. University rating is 4. Statement of purpose is 3. Letter of recommendation is 4. CGPA is suppose 8. And research done or not suppose yes. Let me click on predict. Now it is going to give you a result. That is what will be the chance of the predict admission of that particular student. Prediction chance. Right? So right now this particular application is running on my machine. If you people also want to make use of this particular application, what I need to do is I need to deploy this particular application on some cloud. Right now, see, it has given me the output. Your chance for admission is 7%. Earlier I shown you 92%. So that output was not that much user friendly. But here you can see it's user friendly output. Right now it is running on my local machine. That's why you people are not able to make use of my application. But tomorrow what I will do is I will show you how to deploy this particular application onto cloud, and then you people will be able to make use of my application. So whenever I say cloud, again there are different options. Many people, many of you might be aware about Amazon Web Services, but it's not like that. There is only Amazon Web Services. There is Google Cloud Platform also available. There is a Pivotal Cloud which is also available, right? Then there is something called as Microsoft Cloud, that's also available. Okay, and then there is something called as what is called as Hero. It is called as Hero. So I'll be showing you how to deploy your application. So if you talk about AWS, GCP, Pivotal, Microsoft, for all these clouds, you need to give your credit card details or debit card details. Almost all of them they require credit card, and you can make use of them for 1 year as free. But Heroku, no credit card required, no debit card required, and you can make use of it for 2 years, and you can deploy 5 applications at a time, right? If you want to develop more than 5, you need to delete one, right? So, and creating an account of Heroku is really easy. It's just like creating a Gmail account. So maybe tomorrow I'll be showing you how to deploy your application onto cloud. And then what I can do is whatever the link I will get once I deploy that particular application onto cloud, whatever the link I will get, I will share with people, and you can go and you can use my application. This is what we do in real time. Now, what do you mean by deployment? Maybe some of you, if you are not aware about deployment, why am I talking about this particular thing, deployment? Let me tell you in simple words. Let me talk about this particular thing in simple words, with simple example. See, if you talk about WhatsApp, right? WhatsApp application. Now, just tell me the person, Facebook has developed WhatsApp, right? WhatsApp is the product of Facebook. So the person who developed WhatsApp, if he would have actually kept that particular application only on his machine, will we be able to use that particular application? The people like us would not have been able to use that particular application if that person would have kept the application on his machine only. What he has done, he deployed that particular application, and because of that, what happened? Because of that, now as the application is deployed now onto cloud, now everyone in the world from anywhere in any location, now we are able to make use of that particular application. You can share your data, you can send the message, receive the message, you can share the documents and everything, because WhatsApp is already deployed onto cloud. The same thing I'm talking about. Whatever the application you are able to see right now, it is running where? It is running on my machine, it is running on my local host, on my laptop, right? But tomorrow I'll be showing you how to deploy this particular application onto cloud. So there are 6 to 7 steps only which are required to deploy your application on the cloud, and it is free. No cost is required. Near about 500 MB of application you can deploy, and the application size which I have created, the application size is only 100 MB, 101 MB in our case. So you can also deploy this particular application once you understand the steps to deploy application on the cloud. At most 500 MB of application you can deploy. So, and it is free, right? It is free. So this is what we are going to do in the coming session, right? Okay, so this is how you go and you create a linear model. Okay, let me go and let me stop it. See, if I go and if I stop it, if I once again go and if I refresh it, now it is going to show me error, or it is not going to load anything because I stopped the application now. It is not running. See, this site cannot be reached. Why? Because now application is not running. I stopped it. But yes, obviously it was running on a local machine. Tomorrow I'll show you same application running on the cloud, and then I will send you the link. Okay, so that's what I want to discuss today. For today, we will stop here, and tomorrow we will continue with the next one. Okay, so yeah, start sending your numbers.